Okay, good. Thank you, Paul. So this is my presentation. My name is Conghui. I'm from Robotic Research Center in the Nanyang Technological University in Singapore. So what I'm going to present today is an introduction to RADOE. RADOE means the Robot Application Development and Operation Environment. And we'll talk a little bit about several ROS related projects here undergoing in Robotic Research Center in NTU. So before talking about the RADOE, I'd like to share you information about the ADOE Industrial Robot project here in Singapore. This is actually the 3 years industrial robot research project. It is a very big project. It is kind of national effort project, including 3 universities and 2 local research institutes here in Singapore. So it includes 8 work packages. The first one is the interface. The second one is perception. The third one is planning and manipulation. WP4 is about the control. WP5 is adaptation. W6 and W7 to demonstration. One is for welding and another one is for polishing and finishing. I'm actually a research fellow in WP8 in the RADOE. So RADOE is a core component to integrate the research result of other packages in a common platform. So why we want to develop a RADOE? Everybody knows that it's well known that the current industrial robots mainly work in automobile industry. They are very hard to program. You need experts to program an industrial robot, and it is very hard to operate. And it is showed some kind of advanced capabilities. So in the ADOE industrial robot project, we want to develop some advanced capabilities for the future industrial robots. For example, the interface for human-robot interaction, 3D sensing and perception, and advanced manipulation and adaptive grasping, and even compliant motion control. So RADOE is a kind of platform developed based on ROS and ROS-Industrial. It is an incorporation of high-level robotic software, which has been developed in the other work packages in the ADOE industrial robot projects for different robotic applications. So RADOE is built up on ROS and ROS-Industrial. We use a lot of different packages from ROS and ROS-Industrial. So the segmentation of this RADOE architecture actually divides to 3 different users. The first one is mainly for the developer. We have our full-time research to develop the various work packages and then put it together. And then we have programmers whose role is to link different work packages and generate necessary tasks for the operate. And finally, is the operator who operates the robot is the end user. They will use this result and interact with the tasks. So RADOE plays a role that is seamlessly integration between different work packages. So we have developed a visual programming tool to automatically generate ROS launch files. Then you don't need to bothering open a text editor to write all these launch file and parameters arguments. We have a tool to automatically generate the launch file, and then we have visual and different plugins which can be launched in RV's environment for different applications. And we have the same package release and distribution mechanisms for the packages developed in RADOE. So all these packages are built on top of ROS. So you don't need special configuration requirement for your laptop. So this figure shows a general look of what I have mentioned of these 3 ROS. So in general, we will different work packages will develop the packages which could be launched as a plugin in ROS. We also have different function tools. For example, what I have mentioned about the visual programming tool or natural language interface tool or calibration tool or 3D sensing tool. So we have a user interface. So this is the user interface is the GUI. It's mainly for set up new robotic applications, do some parameter turning. You can access tools and different plugins. For example, on the right side, on the top is a common interface. This is common interface for different robot applications. You can directly control each joint or get feedback from the joint values. The second layer is several tools for different common applications. For example, the visual programming tool or URDF editor. The third layer here is the plugins. For example, we have the natural language plugins, 3D sensing plugins. So when you click this, will pop up interface and connect to the work packages that other research has developed. On the left side is the 3D. We use the ROS, lab ROS to show the URDF model of the robot. So in the below of this dialog, we have 4 steps that you can select different robot you want to use. For example, you want to use UR5, UR10, ABB robot. You can choose different end factor, work cell or work piece, and you can configure it to the location you want to do it. And all this through a URDF editor we have developed in RADOE. So here shows you 2 pictures of the visual programming tool. This tool is very useful to create and maintaining launch files. It's like a lab view in ROS. So you can create the new nodes, set up the arguments, and all these values. And it's very convenient and easy to select, drag and connect different nodes, passing the topic messages, and set up the environment values. With one click, you can create a very complex launch file. We also have a simulator embedded. This helps the robot operator to easily view and verify the task. And we have 2 parts. The first simulator you can simulate in ROS. Another one you can verify in Gazebo. So we also supporting multiple URDF files and trajectory files for the robot operators. So here it shows that we have a plugin which embedded in the Gazebo. So these plugins, you can import the task you have built, and then it can output if this trajectory is valid or not valid. So it can do some validation for your simulation. And the figure below shows we did a simulator for the automated robot taping task, as you show. And we also have intermediate language embedded in RADOE in order to have the same task can be applied into different robots. So you can have the same programming in your RADOE environment, but this program can be executed on different robots. For example, on an ABB or KUKA or on Universal Robot. So we have several applications for the RADOE. The first one is automated robot items picking system. And we are, as the Team Nanyang, we are the finalist of the first Amazon picking challenge in Seattle. And the software package is open sourced. You can follow in the below link to get the source code. And this is the integration of the research works in WP2, 3, 5, and 8 in the ADOE Industrial Robots program. So this system is this is a general view of the whole picking system. So we recently just get an improved version on the right side. This is second version. We are collaborating with 2 local e-commerce companies. We have made a mobile-based improve the robot gripper and the vision system. So you can follow in this link to play the video to see the robot picker it works. So the second demo we have is automated robot taping system, which is for the aerospace applications in order to automate the tape the area that commonly used in the aerospace repairing applications. So the robot actually using a 3D sensor to capture the object you want to tape, and we have an algorithm to automatically generate the taping trajectory for the robot. And we also build this simulator. You can validate your motion trajectory for the robot and see the result. Probably I don't have time to play the video. You can click the link as you want to see it. Another demo we did based on RADOE is a dual arm small parts sorting. We're using a dual arm industrial robot from Next Stage from Kawada Industry, and we did some small parts sorting and the dual arm manipulation. And this is a combination of object recognition, post registration, and a dual arm manipulation. All these packages are available in RADOE as packages and plugins, so it's very easy to configure it. And this project is built by 2 final year students. Okay, other ROS related projects here in Robotic Research Center. The first one is QuickBot. This is a mobile robot to do indoor construction quality inspection. Is already on the news, so you can Google it and know more about it. And there's Ediga for a robot avatar. Is telepresent robot, so we also use ROS to build the software behind of it. The Picto robot on the right side is probably the biggest robot in the world. So it's 3 meters tall. It's used for high ceiling painting. So you can also Google and know more about it. We also have put industry robot for 3D concrete plating and e-commerce picking and B manual operation for example, to assembling a IKEA chair. So for more information, you can visit the website of Robotic Research Center. And in conclusion, the RADOE will be released in next 2 months. So because the A-Star robot is coming to end now, the RADOE has been developed in several successful demonstrations. So we have included different packages from ROS-Industrial, for example, the Move It and the Fermi, and this card for the motion planning. And we also have the industrial calibration tools embedded. So we'll continue integration with other work packages and to increase the RADOE capability and usability. So in conclusion, the ROS-Industrial and the ROS is widely used in different robotic projects here in NTU and in the research institutes here in Singapore. And that's all. Thank you. More information, you can contact with me.